So we're gonna have Amjad come up, and you got a clicker?
Got a clicker.
Oh, he's got a clicker. All right, let's give a round of applause for Amjad.
It's official. Thanks, Cassandra. Actually, it's my first time using a clicker, so I hope I don't screw it up. All right, so you're probably today gonna hear a lot of practical advice. You just heard Preeti talk about static types, and people are gonna talk about React and components and things that you can take home and use. But my talk is not about that. My talk is more about kind of reflection. So like anytime we make a lot of progress, we need to kind of take a step back and reflect and see how we got here and what's good about it and maybe what's bad about it. So it's going to be partly a critique of modern web development tools, and maybe at the end I'll talk a little bit about my view and how we can make things a little bit better. So what's good about the modern development tools landscape? So I'd like to just put it out there right off the bat. It's never been better for web developers. Doesn't matter what you hear on Hacker News. It's great. It's awesome. Small teams can create and maintain very large pieces of software. It's never been like that before. Like a team of 2 can maintain software that needed a team of thousands of people just a few decades ago. And I think largely thanks to our tools. Some of it is our methodologies and the way we collaborate, but I would argue that a lot of it is thanks to our tools. So that's what's good. What's bad, we'll bring up Fred Brooks with laughing down at us and saying, hey, there's no silver bullet. So this paper from the 80s came out, and it was very gloomy. He basically said that, and let me quote him, as we look at the horizon of a decade hence, we see no silver bullet. There's no single development in either technology or management techniques which by itself promises even an order of magnitude improvement in productivity. So basically what he's saying is that from that point forward, we're just going to have a very slow progress in development productivity. It's just going to be very slow, and we're not going to see any single tool or technique that will give us an order of magnitude improvement. However, he also emphasized in a lot of his papers and books that the past breakthroughs in productivity has been largely thanks to tools. He talks a lot about high-level programming languages, which was huge then. And then, most importantly for me, he talked about integrated development environments. But he also always says that he's skeptical that tools will bring us anything other than incremental or marginal improvements in productivity. So here's one quote from his book, The Mythical Man Month. And he talks about how each team needs its own toolsmith. This toolsmith will make sure the tools are running correctly. It will build all the tools you need and for everyone in the team to use. That's things like utilities, libraries, code generators, everything we kind of use and love today. But I would probably argue with Mr. Brooks if I may. And I would say that we didn't have a silver bullet. We had a million silver arrows of sorts. We had open source software, and that was a huge revolution. And now instead of writing your own code, you can rely on millions of developer hours out there open for you to use. And IDEs has been huge as well. There's have been a lot of progress in that. And version management, build and test systems, DevOps and automation. A lot of things went well. So I would argue we've had multiple order of magnitude productivity increases, but largely thanks to our tools, and it's not a single thing, it's a million things. However, with that came a cost. So that quote from Fred Brooks about a toolsmith, I think that's problematic. I mean, every team today, when they start a new project, they have someone go set up, let's talk about web, go set up Babel and React and Webpack and write the Webpack files and the loaders and make sure everything it works together, and that's like an ongoing thing to set up ESLints and all the nice stuff that are coming out, like Prettier, and just an ongoing investment. And I know a lot of you will have someone on your team that is really interested in that, will always keep investing in that. But I find it a little bit problematic that we kind of have that person in every project. And there's so much overlap and repeat work between different projects and different companies, even within the same company. So to give you a concrete example of the problem of this tool fragmentation is, imagine you're writing some JavaScript code today. You open up your editor, and the first step is you write JavaScript in ES 2017. Then, when you hit save, it'll probably be parsed and compiled to ES5. Then, it will be parsed again by Webpack. All that requires will be, or some bundler, all that requires will be collected, and then we would bundle the JavaScript code. Then we would parse it again and minify it. So you can see there's like 3 parse steps here that are exactly doing the same thing. But you think this is done. It's not. The punchline is like when you send your code to the browser, it will parse again and then execute. And if your client is Chrome, it probably is running ES 2016 or ES 2017. So we went this like roundabout way in order to like get the same code that you were writing back to the browser. So there's a lot of repeat work here that that is problematic. So I think despite all the success that we've had in tooling and productivity increases, we've fallen victim to this one-time useful Unix dictum, do one thing and do it well. So roughly speaking, we separate our tools by development lifecycle stages. So there's the authoring time when you have your editor and you're writing code. Then there's the executing, then there's the testing, then there's the building, and there's the deployment. And none of these steps talk to each other. And we try hard not to make them talk to each other. It's almost as if it's a good thing. So this all limits the information for how much the tools can rely on each other and the information they're gathering. So why is that bad? Let's go back to concrete. So everything is slow. A lot of you probably decided to come attend this conference so that you just kill time while Webpack is recompiling. And there's a lot of repeat work that's happening in open source. So a lot of developer time is being killed as well. And code intelligence impact is very limited. So in Preeti's talk, we saw how you can add types to your program. So the types you added will get stripped down when you're minifying. But when your minifier can use those types to generate optimized code. But there's no way it can get that information. So we end up with this information loss as we go down the pipeline. And this artificial separation between writing and running code. We talk about static versus runtime or authoring versus runtime, but it doesn't have to be that way. There are actually a lot of benefits if we forego some of those assumptions. So what if, some thoughts, what if I can get stats on function calls, error rates, type, and other information in my editor? What if I can use autocomplete or click to symbol in GitHub or documentation pages? What if I can build an optimizing minifier based on the type information in my code? What if I have this portable development environment accessible from anywhere or on any device? What if a production crash could translate into a development breakpoint, right? This separation between something running in production and something running on my local machine is artificial. So if something crashes, why not this could be automatically translated into a breakpoint in my app, in my editor as I writing the code. So some of the thoughts are out there. Some of the things are things people built, and there are a lot of experimental projects in this space. So okay, how did we get here? Alan Kay says computing is that's not right. Alan Kay says computing is pop culture, not poop culture. At least I think that's what he said. So let's do better. Let's do better. So he says that pop culture has a disdain for history. So I'd like to make sure that Alan Kay is proud of us today and talk a little bit about the history of how we got here. So let's start with this guy. Richard Gabriel. He was a Lisp entrepreneur. He created one of the biggest Lisp companies in the history of Lisp. And one day in March 1990, Gabriel stood in front of a crowd, just like I'm standing in front of you today, and uttered the words, "Worse is better." The Lisp community and everyone who's who was there, they weren't very happy with the talk. After the talk, a few big names you might recognize, like Jerry Sussman, stood up and claimed nonsense and started kind of chiding Richard about his idiotic talk. So, had the Lisp community understand the lesson behind worse is better, the history of computing would have been different, I would say. To understand this, we need to understand the Lisp community. So the Lisp community also used to be called Do the Right Thing community, also known as the MIT approach, also known as Lisp hackers. And these are actual names. I didn't come up with them. Here's a recent Alan Kay core answer. He talked about, someone asked him, like, how was Xerox Spark different? And is there any organization like Xerox Spark currently? And he didn't answer the last part because that seems obvious. There's no organization like Xerox Spark currently. But what he said, the main, I think, focus of that answer was there was a vision behind what they were doing in that do the right thing, the MIT approach. The destiny of computers is to become interactive, intellectual amplifiers for everyone in the world, pervasively network worldwide. So that was Alan Kay. One of the things that they built is the Interlisp programming environment. And when I look at this, it looks like very 1960s American advertising. It's like, the integration, extensibility, and ease of modification made Interlisp. And then it goes on to say, will enhance the power of the coming world of personal computing and advanced displays. You can see that they had this futuristic vision of what computing could be. So Interlisp was actually very impressive. Interlisp was a bootstrap end-to-end Lisp environment. You can change the environment itself using Lisp, and you can write applications using Lisp. It had a structured editor. So what that means, instead of typing code, you change the AST nodes. So we still don't have that now. They had it back then. It had a REPL, interactive programming and debugging. It had undo, which now is, people call time-traveling debugger, whatever. They had that stuff. It also had automatic error correction. And nobody's even trying to build that stuff. Literally, the computer would try to correct your code. It's like, oh, did you mean? The Google did you mean, but for code. They had that for Interlisp. And many, many more features. Meanwhile, in New Jersey, these guys, Ken Thompson and Dennis Ritchie, and they're like, whatever, man. What if everything is a file? You can see that kind of sounds like a stoner conversation. It's like, what if everything is a file? And everything talks to everything via text. And they started hacking on Unix and C. These guys also known as worse is better, that Richard called them that. Also known as New Jersey style, also known as C hackers. So the C hackers, the New Jersey people, had this core concept of simplicity of implementation. Just build something that works. It doesn't matter if the interface is not simple, as long as the implementation is simple. So we talked about the everything is a file, stoner talk. But what Richard ended his talk with is Unix and C is the ultimate computer virus. They made it so that it runs quite well, and it runs on old machines, and it runs on any machine you put it on, and it just took over. And anyone can copy C, and anyone can copy Unix, and just do their own implementation. So back to Richard. He realized after that talk how destructive it can be. he went back home and he said, he says, like, I survived that talk and went back home, and he decided to hide worse is better forever. And he's like, all right, I'm gonna go about my business. You know, he had a lot of vested interest. He was, you know, his company was the biggest Lisp company. So he hid the document somewhere in his office. Then he later hired this guy. I'm not sure if any of you know who that is, but that's Jamie Zawinski. You can find him at the DNA Lounge in Soma. He's also of the Netscape fame. He really well-known hacker. And you know, the hacker ethos, information must be free. He found that document, worse is better, in Richard's office, and he decided to send it to all his friends. And so what was supposed to be a wake-up call for the Lisp community became a self-fulfilling prophecy. Now everyone, that gives them the kind of the verbiage to kind of articulate what worse is better is about. And it became something that companies taught. I think it's famously IBM taught the idea of worse is better. And it's become this huge destructive force across our industry. And Richard spent the rest of his career fighting his own work under a pseudonym. He started saying things like, worse is better is worse. And I think maybe it got to him towards the end because he was once invited to a panel, and he confused everyone because he was arguing both for worse is better and against worse is better within the same sentence. So he became utterly confused about the problem. A lot of typos. Where do we go from here? Like, so okay, we talked about the history, the problems, and you know, I'd like to put my money where my mouth is, and talk about what we're trying to accomplish. And this is by I didn't try to make this kind of a talk about our company or our product, but just some of the philosophies that I learned from history and how we. Sorry. That Google Fi thing where your phone doesn't ring, but you're. Oh, that's not me. That's you? Okay. I was like, that's not my laptop. You can pick it up if you want.
I find it here, but it doesn't seem to decline it here. Should we take the call?
Yeah, let's do it.
Okay.
All right.
Please turn off your cell phones.
Yeah.
So we started this company called Replit. So some of you may recognize it as this online REPL. And originally we just thought of it as a very good educational tool. You can fire up your browser, go to Replit, and start coding immediately. And that was the idea behind it. But as we made it into a company from a side project and started building the tech, some of these things that I learned from the history of computing started kind of like resonating with me more and seeing how this can be useful. So one of the initial inspirations, I was using Dr. Racket, which is a scheme interpreter. And it had this like two-pane style where you code in one area and then you have a REPL in the other area and you debug that code. That was the original inspiration. So the first prototype of Replit just basically put that on the web. And this is the Y Combinator program in Scheme. And it just made it easy for a lot of students and teachers to start coding. You know, you don't have a laptop, you go to the computer lab, you don't want to install the environment, you just immediately hop onto a new website and start coding. So then we started adding more and more tools. So this should be a GIF. I don't know if they're on here. Yeah. So for example, we added linting. This is for Python, and then we made every package that is ever published on PyPy immediately accessible on the REPL. Then we added step debugging on the same web interface. Then we added file I/O. You can read files, you can write to a graph and see it. Then as we moved into the more education-heavy parts of our website, we built tools for teachers to write unit tests and have them run on the student interface. So you can write the unit test, the students will code, and will run the unit test. So the crucial thing about this is every one of those tools are running in exactly the same service, actually exactly the same binary. So the linting, the unit testing, everything that's running inside this service. So every time you go to the site, we start the service for you. And wherever you go in the site, the service is with you. It will run your code, it will execute it, it will test it, it will do everything for you. So we're starting from the ground up. We're not going to be ready for professional developers anytime soon, but we're starting with education. We're starting with the people that are learning to code. So, so what we're building essentially is a long-lived, always-on service that understands code in all its stages. There's no artificial separation. It can be put at your disposal anywhere you are, regardless of your device, platform, or programming language. So what's next? We're working on deployment. You can deploy straight from the REPL. Code intelligence, maybe autocorrect, maybe bring the Lisp autocorrect back. Coding runtime integration, and a lot more. So I'll turn the question to you. What are you doing about it? Because not one company can solve this problem. I think we need to change the way we're thinking about tools and how we can be more effective and how we can prove Mr. Brooks wrong and that there are silver bullets. Thank you.
Thank you.